Hello, welcome back. In this video, I'm going to be talking about machine learning and the steps to take to make machine learning predictions using Python. So first of all, I'll start off with a quick explanation of machine learning, just in case you don't know. So machine learning is basically the process of being able to look at patterns that are within the data and be able to take those patterns and make a prediction of what is going to come next. So for example, we're going to use the example of machine learning to look at predictions for whether a photo is of a cat or of a dog. So basically, in order to do that, it will need to look at different features. For example, the size, the shape of the cat versus sizes and shapes of dogs, maybe how their mouth looks like, how the shape of their teeth, and this data basically helps it to decide whether or not the photo is a cat or a dog. Of course, machine learning is a very big topic, so this is a very brief a brief explanation. It can go as deep in terms of more areas, because then you could then bring in a photo with a horse into the mix. Then you've only fed it data about cats and dogs, so it's like, oh, okay, this photo is very different, and it can pretty much screw up the predictions. But just as a brief understanding of machine learning itself, it's basically just looking at those patterns to be able to determine on its own if it is a cat or a dog. So you basically feed it and nurture it to be able to make those decisions better and better as it goes along. So that is machine learning. So step number one, which I'm sure is no brainer, you first of all want to import your data. So this can usually come in the format of a CSV file. So after you've imported your data, you then want to move on to step number two, and this is basically cleaning your data. So this is a very important part because you want to maintain the quality of the data that you are feeding in. So this is cleaning in terms of just looking at the data to see if there's any inconsistencies. So for example, if there's any empty columns, you want to be able to remove those columns. Could be inconsistencies such as you have your different rows, so cat, dog, dog, cat, and then one, cat, dog. You want to change that one so you know if it's a cat or a dog. So you don't want to feed in results that can really ruin it and hamper what you're going to get at the very end. And yeah, so it's just cleaning, structuring your data just to improve the quality. And this is a very important stage. So anytime you're working with data and you're feeding it through pipelines, you want to always make sure that your data always upholds its quality, because you don't want to get to the very end and you've put all that work into working with your data to get your results at the end, only to find that the results that you've got is very poor quality and it's not really giving you very good results. And then you realize that it's because you haven't actually cleaned the data properly, and then you're going to have to go all the way back to the beginning just to get that clean. So you just want to be able to minimize that as much as possible. So it's always important each step of the way of maintaining quality of data. Right, so after you have cleaned your data to prevent bad results from occurring, you want to then go on to your step three, and this is basically splitting data into training or test sets. So in training or test sets, what would normally happen is that 80% would be your training model and 20% will be your test model. And this is basically just a way of just ensuring the accuracy of the data and the results that you're going to get. So after this, you move on to step four, and this is creating the model. So there's different algorithms that you can use, and these algorithms are used to analyze the data that you have now ready for this stage. So one example of an algorithm you can use is decision tree, and there are just so many other more out there that you can use. And you want to be able to look at these because there are advantages and there are disadvantages, and you want to be able to use one that best aligns in terms of the end goal of the kind of results that you want to use, the kind of results that you want to gain from the data that you're using, and just kind of really just pick the right one, because it will really greatly affect the results you get. Because if you use an algorithm that is not best suited for the data that you have and the results you want to get, your results are going to come up pretty bad, and it won't be as good as another algorithm that suits it better in terms of its advantages and disadvantages. So there are libraries out there of algorithms that you can use, so that way you're not coding it yourself. So it's great. It's a great community, something I'm learning myself. You know, coming into the data world, that there are libraries out there that you can use for your coding, and it's just great, this community of support online with helping you to get the you know, the answers that you need. So there are libraries out there to help you through the use of your algorithms. So next you go on to stage 5, and this is training your model. So now this is you telling your model to go away and basically search for the patterns in the data. And this is very crucial because from looking at the patterns, we then move on to stage 6, which is basically telling your model to make a prediction. So it's looking at these patterns that are gathered in the other stage, and it's now giving you a prediction. So it's telling you whether this photo is of a cat or a dog. Now at this stage, especially if you're running this for the first time, it's important to remember that it's not always going to be accurate, because it's something that needs to be looked at, improved, developed over time, and it needs constant feeding as well in order to make better and better predictions. So now you make your prediction in this stage. So after you have completed stage 6 of making the prediction, we then move on to the final stage, which is 7, and this is us basically evaluating and improving it. So we're looking at how accurate is this result, how accurate is the data that we've been provided, and it's basically just looking back to see where you can improve it to be able to make better results. So this could either be looking back at the algorithm. So if you did use a decision tree, for example, maybe you want to see if another algorithm is better suited, and you want to see if that's going to give you a better result than the decision tree did. Or it could even be as much as just looking at the parameters that you have chosen and just tuning it just to see if that's going to give you better results in the end. Or if you haven't been keeping up with the quality of the data, like we discussed before, you'll be going back all the way to stage 2 of cleaning the data just to make sure that data is good quality. So yeah, this is a very important stage as always, to just be able to look and evaluate it and improve it, because you want it to be the best results as possible, because you want it to give you the best idea, the best insights, whatever it is you're looking for. You want it to be right, correct, the best it can be. So thank you for watching this video. I hope you did learn a lot about machine learning, and if you have any questions, please feel free to put it into the comment and I'll be able to come by and look at it. It is a very exciting topic. Me myself, I have enjoyed learning this topic because I am on my own self-learning journey of the data in the data world. So I hope you enjoyed this video. Give it a like and subscribe. Thank you for watching.